Hi guys, welcome to our second video in chapter 9. This is section 9.2 and it concerns naming molecules. Remember, our question for chapter 9 is why can we melt sugar on a stove but not salt? First, when we're naming molecules that are just one type of element, it's very easy. You just give them the name of the element. So for example, H2 is called hydrogen, O2 oxygen, Br2 bromine, etc. So if it's just one element, just name it that. Good. Moving on. Let's talk about what happens when we name binary molecules. Binary molecules have two types of elements, like H2O and H3, any of these examples down here. So just two types of elements. We got 3 steps, and step 3, I put a little asterisk by because there is going to be a special consideration here. So I'll make that look less like the letter A. But anyway, so let's name, for example, H2O. And no, it is not named water. That's what's called the common name. We are going to give the systematic name for water, right? The actual chemical's name. So to begin, it says the first element in the formula is always named first using the entire element name. So here I have H. That is called hydrogen. And hydrogen, cool. I'm going to make sure it's not capitalized, but hydrogen. And then the second element in the formula is named using the root of the element and adding suffix "ide." So where our anions got the "ide," here it's just the second element gets the "ide." So oxygen becomes oxide. All right, cool. So I'm going to make this red so we can see that it's like my answer. But now let's look at step 3. Oops. Let's look at step 3, which says that we need to use prefixes to indicate the number of atoms of each type that are present in the compound. So if I look at my hydrogens, I have 2 of them, and I see that for 2, my prefix is in fact di. So this would be dihydrogen. And then, so dihydrogen, and then for 1, I have 1 oxygen, that becomes mono. So dihydrogen monoxide. And no, you don't have the extra O, it's not monoxide, it's monoxide, right? So dihydrogen monoxide, this is the chemical name for water. Excellent. Let's move on to our second step here, right? So going through, I'm going to name this, of course, our first element is carbon, and then my oxygen becomes oxide. Cool. And then my prefixes, right? I've got 2 oxygens, so I'll call this dioxide. But hold up, you've probably heard of CO2, and you know that it's called carbon dioxide. It's not called monocarbon dioxide. And the reason for that is why I have this asterisk over by number 3. So let's make a note that we can write out for the, say when the first element has 1 atom, omit mono. So that means if they're, for example, in CH4, PH3, CO2, we're going to make sure we don't actually write out that mono. We're gonna ignore that when it's the first element. So this is just carbon dioxide. Looking at CH4, I see my first element. There's only 1 of them, so that name is not going to change. So that will stay carbon. And then I have 4 hydrogens. The prefix for 4 is tetra, so carbon tetrahydride. Cool. And then last example, I have my PH3. P is phosphorus. There's only 1 of them. Phosphorus, and then I have 3 hydrogens. So that would be trihydride. Trihydride. Oh, spelled it wrong. They spelled it wrong. BRIDE. Anyway, the spelling is probably fine, but anyway, so that's how we add names to binary compounds. All right, moving to some more complex concepts here. We need to talk about how we could name acids. An acid is defined as a substance that releases H+ ions when dissolved in aqueous solution. A base is either a substance that reacts to remove that H+ from solution, or it could release OH- into solution. OH- reacting with H+, of course, in removing it from solution. Something important that you need to know is that this is a really, really big topic. It's so big, in fact, that all of Unit 19 is dedicated to acids and bases in their chemistry. So we're just going to touch briefly about how to name these things because they are covalent molecules. If you look in your reference table at table K and table L, you'll find some names of common acids and bases. And this is very, very useful. This is gonna allow you guys to skip a lot of steps when you're trying to name acids here. So please make sure you're using a reference table to look at these things. So let's look at what we do if we're naming a binary acid. And this is just something that has hydrogen and another element, right? So it can release that hydrogen. And it's actually pretty straightforward. You just take the prefix hydro to name the hydrogen part of the compound. Then you just take the rest of the element, the second element, and add ic acid to the end of it. So let's, sounds weird, but let's look at HCl. Well, I'm going to start by naming the hydrogen. So that is, of course, going to be hydro. So I'm going to name this hydro. And then I'm going to take my chlorine, and instead it's going to get the suffix ic. It's the suffix ic. So it becomes, from chlorine, it becomes chloric. So hydrochloric acid. Right? I don't know why I have H2O here. What I meant to have was H2S, right? So H2S, well, we're going to name our hydro, right? Name the hydrogen. So hydro and hydro. Oh, sorry. By the way, guys, these are one word. So hydrochloric acid is one word. Hydro sulfur becomes sulfuric acid. So hydrosulfuric acid. No, these are one word. Hydrosulfuric acid. And then HBr becomes hydrobromic acid. So I'll write that out. Hydrobromic acid. One word. So that's how we name binary acids. An important factor to note, of course, you know all about polyatomic ions from our ionic bonding chapter. When you're trying to name an acid that includes a oxyanion, you are going to be naming what's called an oxyacid. So oxyacid is just an acid containing an oxyanion, or a polyatomic ion containing oxygen, right? That's an oxyanion. So the name is actually very easy. You name the oxyanion, and then you add acid at the end of the name. So for example, HNO3, my NO3, if I find it on my reference table, NO3 is right here, nitrate. So that becomes nitric acid, right? So we have our oxyanion of nitric acid here. Where can I stop right here? So this becomes nitric acid. H2SO4. SO4 is our sulfate. That's going to become sulfuric. So this is sulfuric acid. And then H2SO3 would be sulfurous acid. So sulfuric, nitric, sulfuric, and sulfurous acid. So just referencing your polyatomic ions table is enough for you guys to be able to get these oxyanions and oxyacids. I'm not super worried about these. So just make sure that you're using your reference table and you'll be fine naming oxyanions. All right, so there's a branching decision tree about how we would go the other way and write formulas from names. So step one, of course, you want to look at the molecule. And then you want to decide, is it an acid? If it's not, it's very straightforward. Use the prefixes that you see to determine the number of each element. If it is an acid, you need to decide, is it an oxyacid or is it a regular acid? If it's a regular acid, just take the root of the element as your element that's not hydrogen and add enough hydrogens to balance it out. If it is an oxyanion, go ahead and use your reference table to figure out what that species actually is. All right, guys, that's it for this video. I'll see you guys in the next one.